For algebra 2 with trig, this is day 3's homework. We're going to take this equation, y equals negative 0.034x plus 8.7, which uses points allowed. So in a football game, when you allow points, you have a better chance of losing. Uses points allowed to predict the number of wins. So if you allow points, you're going to lose less games. That's why we have a negative slope, because if you have a larger number of points allowed, then we're going to start to lose more games. If you look at this from a XY axis point of view, this would be the allowed points, and this would be the number of wins. If we're going to win about 8.7, and then our slope of our line is negative 0.034. That is the slope of the line. So it's very close to 0, but it is negative, so it's falling. So the number of wins will slowly decrease by the number of points that's made. So interpret the slope of the best fit line. We know that the slope is negative 0.034. For every point allowed, you would lose 0.347 of a game. Now that's kind of weird. How do you lose a partial of a game? But at an average, looking back at values, if you lose too many points, that is eventually going to turn into 1. If you eventually lose tons of points, that's going to turn into losing multiple games, which means it's less than 8.7, which is telling you the number that you won. The Y-intercept. The Y-intercept here, the B value is 8.7. Of course, you can't win a partial game, but in terms of the averages, it comes out to be from 8.7, then we start to decrease, and we can start to see how many wins you would have if you allow points. So the team that's going to allow the least amount of points is going to win more games. Does the Y-intercept have meaning in this context? This Y-intercept can't actually occur. So I would say no. You can't win 8.7 games so we'll just leave it at that. Can't win 8.7 games. So in terms, that doesn't seem to exist exactly here, but if you allow 0 points, then you win games. That would be a true statement. So it depends how you look at it. If a team allowed 110 points throughout the course of the season, approximately how many wins would you get? You allow 110 points. So you notice that that's going to be decreasing from 8.7. So we have a negative 0.034 times 110. So we're looking at negative 3.74. And we're going to do that from 8.7. So they're expecting us to win approximately 5 games. So it's exactly 4.96. So it's good to show the real answer. You can't win a partial game. So they're saying in this formula we'd win almost 5 games if we allow that many points. For our next question, we're looking for the equation of the best fit line. We have the number of minutes for each player. We have the number of points that they scored for each game. Now we're going to look for the line that would best connect all of those. So we take our graphing calculator. We hit Stat. We're going to edit. We have to get rid of maybe what's in your list, so you hit clear. Don't hit delete. Hit clear and then enter. Plug in the number of minutes per game. Once you type in all the minutes, now type in all the points that each player received. So we start with 17.9, and that has to go with the 33.4. Now you've completed typing in all the points for the second column. So we're going to write an equation. So Stat over to Calc, down to Linear Regression. My calculator here is not showing that the same screen. Sometimes it says L1 at the top and then L2, saying what your X and your Y are going to represent. As long as you typed your data in list 1 and 2, you can just hit enter. If it's something different than that, you would put L2, L3 in this location. But I put my information in list 1 and 2. I hit enter. There is my equation, my best fit line. 0.48 is my slope. We can round that up a little bit. Negative 2.4 is my Y-intercept. Round to the nearest tenth. So we have 0.5x minus 2.4. So in other words, for every minute that they play, they're going to earn a half a point minus 2.4. So the more minutes you play, the better chances of you getting more points. On average, this is what's happening for the team. So if we're going to play 15 minutes, and we plug that into our calculator, we're going to get 5.1 points. And looking here on our list, a number around 15, less than 15, less than 5. Double the 15, definitely double the 5. To interpret the slope of the best fit line, for every minute played, you earn half a point. That's what the slope would stand for. Interpret the Y-intercept of the best fit line. That's negative 2.4 points. Well, in this case, if you played 0 minutes, would you earn negative points? Okay, and that doesn't have any context in this. Where above it talks about winning 8.7 games for the football. You can't win a partial game, but at least allowing 0 made you win games. That made sense. In this case, if you don't play, you're going to earn negative points. That has no context in this scenario at all. You can't earn negative points. There's no context. Okay, find and interpret the value of the correlation. To figure out the correlation coefficient, we're going to come down here to catalog, down at the 0. So second 0. Then you have to hit the D, which is the inverse key, and scroll down a little bit farther to get to diagnostics on. You got to tell your calculator to show this special category in diagnostics. So when we go back to stat, calc, and linear regression, and it shows us the slope and the y-intercept, it shows us our correlation coefficient, 0.93. That tells me that the points are about 93% accurate with the line that we have written. So the R value is going to be 0.93. So in other words, the line has a strong correlation with the points. That means the points would be pretty close to that line. Whenever you're in the 90s, that's a pretty strong correlation. On our next page, we're looking at the team's equestrian club wants to rent stalls in a ranch. So if they rent one stall, they're going to pay $600. If they rent 2 stalls, 2 spots to put their horses, it's $500 for each stall, $300 for each stall. And then the next one's easy to work with. If they rent 10 stalls, move the decimal spot over because you divide it by 10. Each stall is $225. So it pays to rent more stalls. You get cheaper per stall. So we're going to go to Stat and Edit. We'll clear out the data from lists 1 and 2, and we'll type in one, 2, 5 actually, 7, 9, 6, and 10. Then put in the numbers that correlate to those. So you have a cost for every number of stalls that you make. You want to be sure that the amount of numbers is the same in both. And then you go back to Stat, over to Calc, down to Linear Regression. Your screen might look a little different than this, but by hitting Enter, we can see what the slope would be, what the y-intercept would be, and what the correlation coefficient would be. So I see, rounding to the nearest tenth, that would be $176.50 for every x, which is the number of stalls, plus 541.5, and the correlation coefficient is 0.98, which would be a pretty strong correlation. What is the slope? The slope would be $176.50 for every additional stall that you rent. Whoops. Interpret the slope of the best fit line. That's the slope. The units would be dollars per stall, and that would be for every stall that you rent, you're paying $176 more dollars. That's an average when you take all the points put together. Find and interpret the Y-intercept of the best fit line. The B value is your Y-intercept. You're looking at $541.50. Does that make sense? So the question is, if the Y value is the money, and this is the number of stalls, if you have 0 stalls, are you going to pay $500? No. So, does it make sense in this context? It does not, or doesn't make sense to pay $541 if no stalls are rented. So in this case, the Y-intercept doesn't make any sense. The correlation coefficient is 0.98, which is telling us that the line and the points are about 98% accurate. There is a strong correlation between the number of stalls and the cost. Approximate the cost to rent 3 stalls per month. Well, if you have an equation of 176.5 times 3, but we're going to start out with a flat fee of $541, using your calculator, 176.5 times 3, and then add 541.5 to that, we're going to get $1,071. If you compare that to what we have up here, at 2 we're paying $1,000, at 5 we're paying $1,500, so 3 is in between those two, which is going to be $1,071. Alright? So here we're going to look at trying to come up with the best fit line. A couple different ways. You could type it into your calculator, each of these points, and see what happens. You could come in and see if this y-intercept was at 3 and had a slope of 1, 2, 3, 4, 5, 1, 2, 3, 4, that line would seem to go right through it. Sounds great. So this is looking pretty good. We're down at -2, which sounds like an awful idea. Up 3 over 2, nowhere close. Start at 4 and have a negative slope, not even close. Start at 4 and have a slope of 2, not following that same line. So here's going to be the best because we have a y-intercept of 3 and a slope of 5/4, which means that the line is going to follow right through there.